Alright, so now we are going to discuss about the height and distance. Basically the theory behind height and distance and the formula that we'll use in the height and distance problem. Height and distance are quite easy problems to solve, and direct questions are there from height and distance, although they will modify it in CSIR NET examination a little bit with real life examples that there's a tree, there's a pole, or there are two ships moving in the opposite direction, like that. Or they will also ask us question regarding, eagle is flying from the top of the tree to catch a snake is in the ground, and the hypotenuse will form by the direction of movement of the eagle. This kind of events will be told to finally find out and get your answer, height and distance. Okay, so what are the formula? But there are too many formulas that we need to remember for height and distance. So very easy. Basically this table is the important one that you need to go, and particularly what you need to understand is the table for tan theta, not the other ones important. Tan theta is the most important one. And the basic of trigonometry says there are three different components of a right angle. So it's a triangle with a 90-degree angle in the center. So what we have here is we have a perpendicular, we have a base, and we have this hypotenuse. Okay, so base is x, perpendicular is y, hypotenuse is r. So sine theta is what? Is perpendicular by hypotenuse. Cos theta is base by hypotenuse. Sine is perpendicular by hypotenuse, this by this. Cos is base by hypotenuse, this by this. And tan is easy one. It is perpendicular by base. It is this one by this one. And we know the Pythagoras theorem that we can find out this hypotenuse and the value of hypotenuse from the values of base, this one, and perpendicular, this one. Okay, and so what we can easily say, sine square theta plus cos square theta 1, sec theta minus tan square theta equals 1, cosec square theta minus cos square theta equals 1. So basically sine square theta plus cos square theta 1, this can be used, but most of the time we need to look for this trigonometry values, and the values goes 30 degree, 45 degree, 60 degree. These three values are important. 0 degree and 90 degree is not that important. So this 30, 45 and 60 degree values for sine theta 1 by 2, 1 by root 2, root 3 by 2. Okay. If you know that, rest of them are quite easy. 1 by 2, 30 degree, 1 by root 2, 45 degree, root 3 by 2, 60 degree. For cos theta, it's the reversal. That is, the sine 60, the value of cos 30 is the same as sine 60. 45 remains the same, 1 by root 2. And value for cos 60 is the value of sine 30, that is half. So 1 by 2, 1 by root 2, root 3 by 2, opposite, root 3 by 2, 1 by root 2, 1 by 2. What is the value of tan theta? Quite easy. You take this upper value, that is 1 from here, 30 degrees value, and root 3 here, so 1 by root 3, and the 45 degree is this 1, and 60 degree is this root 3. This is how we can remember that quite easily. Okay, there is no logic behind it, but we can remember that quite easily. Now in height and distance, there are two kinds of angle will be discussed. One is the angle of elevation, another one is angle of depression. Angle of elevation is one a person is looking at some direction from the ground, that is angle of elevation. Angle of depression is someone is standing on top and looking at the bottom, angle of depression. But angle of elevations, the direction, angle of depression's direction, that direction becomes the hypotenuse. That is the hypotenuse value. So whatever value it is, the angle value that will be given is known as the theta, and that's what we are calculating here. Sine theta, cos theta, tan theta, the value, and the angle of depression and elevation can be 30 degree, 45 degree, 60 degree, whatever values in between. You can easily calculate the value from value of 30, 45 and 60. From that value you can calculate the relationship between the hypotenuse, base and perpendicular. Okay, so basically if they give us the value of base or hypotenuse or perpendicular, any one of this, and along with that the value of theta, we can calculate the rest of the two. Okay, this is how we can do that. And angle bisector theorem is there. Considering this idea that ABC is shown, let the angle bisector of the angle, so angle bisect D is bisecting, then what we can say is that BD. So basically what we can say, the angle bisector A intersect BC at a point D. So this BD, so BD by DC, this by this, will be equal to AB by AC. This is always true. This BD by BC BD by DC, this BD by DC will be equal to AB by AC. This and this and this length will be equal to the ratio of this two. Okay, very important, remember that. It will be useful in some mathematical problems, but not all, but some. Okay, and remember some values to be memorized, and that is root 2, root 3 and root 5 values, because you can see that here we have 1 by root 2, 1 root 3, all these values. So you need to remember root 2, root 3 values. Root 5 is not that important, but root 2 and root 3. Root 2 1.414, root 3 1.732. Root 5 2.236. These three root values for root 2, root 3 and root 5. Remember that. Root 2 1.414, root 3 1.732, root 5 2.236. Okay. If you know this part till this point, basically most of the problems you will see will be using only the formulas, only the tan theta formula, because they ask question related to the perpendicular, the relationship between perpendicular and the base. Okay, or even between the base and hypotenuse, we simply utilize the formulas separately. We don't use it sine, cos and all these others, mostly tan theta and cot theta, which is inverse of tan theta. Okay, so now we are going to discuss some problems from height and distance. We have seen the formula, and height and distance is a section of part A where you need to remember some formula. They ask some question from the formulas. Okay, so we'll talk about this height and distance formula now. We have talked about it, so we'll start solving the problem. So first I'll take the color here, and then we'll start talking about it. Okay. So a man is observing from the top of a tower a boat speeding away from the tower. A man is present on the top of the tower, observing from the top of the tower that a boat is speeding away from the tower. So now then says the goat makes an angle. Basically it will be the boat makes an angle. It should be a boat makes an angle of depression 45 degree with the man's eye when a distance of 60 meter from the tower. After 5 seconds the angle of depression becomes 30 degree. Find the speed of the boat assuming that it is running in still water. There is no current against the direction of the flow of the boat. Okay. So now what is the situation? Again, let me explain the situation for you. Let's say this is the tower, and let's assume this AB is the height of the tower. This is the height, small h is the height of the tower, and the base of the tower is this, that is, let's say the base, this is D there, the base, and the person is standing at the top of the tower, that is the point A. Okay, and at the very beginning the boat is present here at the point C. So we are going to see a straight line. This is the angle, and the angle of depression was 45 degree at the beginning. So this is 45 degree angle, and then the boat is going away from the base of the tower. So now the boat is in the point D, and at this point D, so if I draw at this point D, what is the angle? The angle is 30 degree. The angle became 30 degree. 30 degree angle. Okay, 45 degree earlier, now 30 degree angle of depression. So what we need to find out? We need to figure out when a distance. So the thing is, when the man's eye at a distance of 60 meter from the tower. So at a distance of 60 meter from the tower means basically this distance is given. You can see that with a man's eye at a distance of 60 meters from the tower, after 5 seconds the angle of depression changes. So this is where the angle of depression is there. So this is 60 meter. Okay, the value is given. The height we don't know. Let's say h. What we need to find out? The speed of the boat. The speed of the boat that we need to find. Okay, 5 seconds the angle of depression changes. So this is the point where the angle of depression was 45 degree. In 5 seconds the angle of depression changes to 30 degree in a water, and the water is still in this case. So what we need to figure out is the value. So we need only 60, that is CB. We need the CB is 60 meter. CB is 60 meter. CD, what is the value of CD? We don't know that. Let's assume that is x meter. CD is x meter. So now BD will be 60 plus x meter. That will be the assumptions out there. So what we can tell from here is actually very easily. If you look at here, this tan 45 degree. This is the 45 degree here. So tan 45 degree, that will be h by 60. Height h by 60, that's the value. So from this what we can get? H equals to 60 into tan 45 degree. And what is the value of tan 45 degree? If you recall the formula, 1 So height is 60 meters also. So CB is 60 meter, AB is also 60 meter. We found it out just now. Okay. That is the very first idea here. So then what we will say that the next, so this angle is done for the smaller triangle, 45 degree angle of depression, that is done. Now for the bigger triangle, again we'll write tan 30 degree. We'll write tan 30 degree equals to, tan 30 degree equals to, what will be the value for tan 30? That is AB, this total height, AB by BD, by BD. So AB by BD, what is AB here? We know what AB is. The value of AB we already found it out, that is 60 by BD. What is BD? BD is 60 plus X. 60 plus X. 60 by 60 plus X. This is what we know. And what is the value of tan 30? If you recall, 1 by root 3 is the value for tan 30. So simply what we can say, 60 plus X equals to 60 root 3. This should be the value. From here what we can find out, X equals to 60 root 3 minus 60. So from there what we can find, 60, and inside of which we will, what we will get, root 3 minus 1, and the value of root 3 is 1.73. I said that you need to remember the value of root 3, that is 1.73. 1.73 minus 1, 60 into 0.73. So that will give us 43.8 meter. So we got the value of X. Got the value of X. Let's change the color for your understanding. And let's say this is 43.8 meter. This is 60 meter. So total 103.8 meter, the base. Okay. So basically now what we know, that this X is 43.8 meter, and what is the time taken for the boat to move from C to D? 5 seconds. Right? 5 seconds. So what will be the speed of the boat? So this is 43.8 meter, that is done. That is the movement in 5 seconds. So in 1 second, the movement of the boat is 43.8 by 5. That should be the value. That much meter per second, isn't it? 43.8 by 5 meters per second. Now the question said the speed in kilometer per hour. Now this is always something in speed and distance, time and distance problems. We'll discuss about this. And if you check that earlier, you know that we can easily convert meter per second to kilometer per hour. We can do that. And what to do? We need to multiply this value, 43.8 divided by 5. We need to multiply it with 18 by 5. Once we multiply, we'll get the value. And in this case, what value we will get? Let's put it into the calculator. In my case, I got 31.5 kilometer per hour. 31.5 kilometers per hour. That is option B. So option B in this case would be the correct answer. That is how you can solve this problem. Although you see, this problem seems complicated, so many other calculations, but actually we only needed tan 45 degree and tan 30 degree formula, and rest is very simple. The important thing about this kind of problem is that the ability for you to draw this diagram, it's very important, because if you draw the diagram, the rest of the process is very, very simple, very easy. Okay, the rest of the process will be easy. It won't be that of a big deal to answer it. Alright, because in height and distance there are simpler problems, but in CSIR NET examinations they are going to ask you some practical example problems that we saw. Now this is another practical example problem. A peacock perched on the top of a 12-meter high tree spots a snake moving towards its hole at the base of the tree from a distance equal to thrice the height of the tree. The peacock flies towards the snake in a straight line, and they both move at the same speed. At what distance from the base of the tree will the peacock catch the snake? See, in these cases, if the question are bigger, you may need to read it couple of times. So the basic thing is that basically what they said is that 12-meter height, this is a tree, and let's assume the tree, this is AB, the tree, and this is the thrice, BC is the distance. This is where the snake is there. Snake is present in the point C, peacock is present in the point A. Okay. Now what they say is that BC equals to thrice as AB. This is what they said already. Okay. BC equals thrice as AB. AB is given 12. So BC equals to 12 into 13, that is 36 meter. And the other thing is told is that the peacock is moving from C towards the base of the tree, that is B. And there is a point where the peacock catches the snake. The peacock catches the snake. Sorry, the snake is moving from C towards B, and let's say D is the point where the peacock catches the snake. This is the point. Okay. And we don't know what this BD is, what this DC is. We know the total distance 36 meter, but we don't know what BD is. We can easily find it out though, isn't it? We can easily find it out. Let's assume BD equals X. Let's assume BD equals X. Let's assume that X meter. Okay. So if BD equals X meter, we know BC equals 36 meter. So DC equals 36 minus X. 36 minus is the DC, this one, 36 minus X. Okay. We know that. So now we have two different angles. Two X, one smaller angle, another one is a bigger one. Okay. So now from which angle? From the angle ABD, smaller angle. Let's consider the smaller angle, this one, the smaller angle ABD, this angle. So from angle, from the triangle ABD, this particular triangle ABD, what we know? AB equals 12, BD equals X. Okay. AD, BD equals X, AD equals what? AD equals what? What will be the value of AD? Do you know that? What will be the value of AD? Basically, the value of AD will be equals to the value of DC. This value and this value must be equal in this case. Why? Because it states, read this question, the peacock flies towards the snake in a straight line and they both move at the same speed. So basically, the time taken to reach from C to D, they are moving the same speed. So the distance that is CD, distance that is AD are equal, isn't it? AD equals CD. Got it? This is very important, that AD equals CD. To know that AD equals CD, without knowing that you cannot even solve this question. Let us take a different color now. What we know, that the speed at which the eagle is flying from A towards D and the speed where the snake is moving from C towards D are same. So if the speed are same and they catch each other at this D point, so DC and AD are same, equal. AD equals CD, equal. So CD was 36 minus X, so AD is also 36 minus X. So we know all these three. Now if we know these three, hypotenuse, we know perpendicular, we know the base, we know we can apply Pythagoras theorem. What is the theorem? AD square, that is hypotenuse square, equals to AB square plus BD square. We can easily write it. So 36 minus X, that is AD, the value of AD, if we put it, AB square, what is the value of AB? 12 square. What is BD? X square. So now only thing that we need to do is to simplify this equation. That's it. That's all we need. And if we simplify this equation for you, it comes something like this. Equals this. From there we know we can cancel x squares and from both the sides. 72x equals to 1296 minus 114. Do that in calculator, that's giving 1152. So I'm jumping one step in some cases because I'm running out of space here. So from here we get 1152 by 72 and that gives us 16 meters. See the option A is a 16 meter. So the X is 16 meter. What is the answer? At what distance from the base of the tree will peacock catch the snake? That means from B to D. They actually wanted us to find out BD. So actually want us to find out X. The value of X is 16. So 16 meter is the distance at which they will catch, the eagle will catch the snake from the base of the tree. Quite easy, right? But the very important concept in this particular problem is to know that AD equals CD. AD equals CD. AD, this distance, equals CD. If you don't know that, you cannot solve it. Okay. Now another question. Now I'll solve another question here. Here, the angle of elevation of the top of two vertical towers as seen from the middle point of the line joining the foot of the towers are 60 degree and 30 degree respectively. The ratio of the heights of the tower is. So basically I mentioned you that this problem depends on your skill of visualizing, and not only visualizing but also to draw by reading the question. The angle of elevation of the top of two vertical towers as seen from the middle point of the line joining the foot of the towers are 60 degree and 30 degree respectively. So if I try to draw, this is the base, this is one tower, okay, this is one tower, and you see the angles are different. That means obviously the height of the towers are also different. So let's say one tower is tall, one is short. From the base, from the
is 1 hour.
Alexa, stop. So what we have here is that we have from the center point, it says from the center point joining the line of the foot of the tower, this is the center point. So for this tower, this is flat angle. For the same point, this tall tower, the angle is sharp. So there are two different, this is smaller angle 30 degree, this is larger angle 60 degree. Okay, and let's put the values here. Let's put AB, this is tower number 1, and let's put CD, that is tower number 2. Okay, the angles are given, and let's say the height, let's say this long tower height H1, the short one is H2. And what else we need to know? This is the common point, let's say O is the common point, and this distance, that is AO equals OC, both are same. AO and OC, they have the same distance. Let's talk at the distance of X. Let's assume that the distance here is X. AO equals OC equals X. Okay, and now the height, AB height is H1, CD height is H2. That's what we mentioned. The ratio of the heights of the tower, we only need the ratio of the height of the tower. We don't need anything else. So now basically what we need H1 is to H2. We need this value, right? So for that, what we'll do, we do tan. So tan 60 degree equals what? AB by AO. AB by AO, that is H1 by X. That's the value for tan 60 degree. On the other side, if you look at tan 30 degree, what is the value? CD by OC. CD is H2, OC is X. But the values are different. The values for tan are different, right? So now what we need to simply write the value of tan, and you need to remember the value of tan. I always mentioned that the value of tan would be the most important one that we use. Tan 30 degree. So tan 30 degree was what? What is the value of tan 30 degree? Recall 1 by root 3. So what will be the value here? Root 3 H2 equals X. So basically H2 equals X by root 3. So that is the height number 2. For height 1, tan 60 degree. What is the value for tan 60 degree? Tan 60 degree is only root 3. So H1 by X equals root 3. So H1 equals to root 3 X root 3. So what is the height, the ratio of the heights of the tower for 60 degree and 30 degree respectively? So 60 degree tower will be on the top. So 60 degree tower means this one. The height is H1 by H2. So the height H1 X root 3. H2 is X by root 3. X by root 3, isn't it? So what would be? 3 on the top, 1 on the bottom. Because that's the value. X will cancel each other out and it will be 3 by 1. So 3 is to 1. H1 is to H2 would be 3 is to 1. And option D carries the ratio of 3 is to 1 here. So that should be our correct answer, isn't it? See, this question is even a lot easier compared to the last two questions. These are all previous year CSIR NET questions. So if you are able to solve this kind of questions, you kind of know how to solve this kind of height and distance problems.